this video, I'm going to go through how to process the MicaSense dual cam data sets from a MicaSense RedEdge-P dual cam system. So it's a 10-band system plus the panchromatic band for pan sharpening. So I'm going to do this in Metashape, and to start the process, I'll bring in the dual cam data set. So if we go to workflow in Metashape, I'm going to add the whole folder. You could add photos if you want. I'm going to add the folder. It's a multi-camera system, so I'll select multi-camera system. And then the images are brought in to Metashape. As I demonstrated in the other tutorial video on the RedEdge-P data, I could clean this up, but this is pretty tidy already. You'll notice that there are no calibration images in this data set. Unfortunately, I don't have those, so I'll show you that step, but we're not going to use any radiometric calibration process. So the images are in already, and the first thing I'm going to do is I'm going to well, first of all, I would go, if I were to do the calibration, I'd go to calibrate reflectance, and then I'd hit locate panels, it'd find the calibration images, and then typically it would populate all of these with the reflectance data for that calibration image, but I don't have that, so we're going to skip this step. And then the next thing that I'm going to do is I'm going to set the primary channel. I'm going to set the panchro band as the primary channel, and then we can start the process. So the first step is to align the photos. I'm going to leave all the settings as what they are, and I'll hit OK. Got to name the project, so I'm going to name it RedEdge-P Dual. And it is starting to align the photos. Aligning photos is done, and you can see them in the viewer. And it looks like they're pretty bright already, but if we want to see these images better, we can go to Tools and set brightness, hit Estimate, and Apply. And we can brighten them up so we can get a better visual of what they look like. If you right-click your mouse, you can move around the data set. If you left-click, you can use the trackball to look at the data in different ways. But once the aligning is complete, then we can move on to the next step, which is, if we go to Workflow, we can build a model. We could actually jump right to build DEM, but I'm going to build the model first, and then I'm going to build the DEM. There we go. Models created pretty quickly. Then we go to Workflow again, and we can build point cloud. I'll leave settings the same. Point cloud has been generated, so now we can go to the next step, which is building the DEM. And I'm not sure exactly what this does, enabled versus extrapolated, but I was always taught that extrapolated is the way to go. And we'll use the point cloud as the source data. You can also use the model as the source data, but that takes a little bit more time. It's a bit more intensive. Okay, DEM is generated, and we can take a look at that by clicking on the drop-down menu here and double-clicking DEM. It'll show us the DEM. Now we can go to build orthomosaic. And we'll use the DEM as the surface, mosaic, hit OK, and this will take a little bit of time. This is probably the second longest process next to aligning photos because it's generating 11 orthos for the 11 layer orthomosaic. Okay, orthomosaic has been created. We can double click on that and we'll look at the panchromatic band of the data set. You can see these are field trials. It's a field trial data set. Spatial resolution is pretty good because it's the panchromatic band. And what we can do now is we can pan sharpen the other 10 spectral bands because they're lower resolution than the pan band. So we can go to Tools and then where is it at? I think we go to Orthomosaic and then Pan Sharpen. So this is pretty intuitive. So low resolution ortho, all the bands except for Pancro, so we uncheck that. And then we uncheck all the bands except for Pancro and the high resolution so that Metashape knows which one to use as the reference point for the pan sharpening. And then I like to clip result to high resolution ortho to make sure that there's no overhanging lower resolution multispectral data outside of the Pancro. Now that's done, we've got the pan sharpened ortho over on this side. And that's the end of the processing. So now we can just export this and take a look at it. So we'll use QGIS to take a look at the data, and maybe we'll make some composites to show different band combinations. So to export, you can right-click and export. I'll name it Dual P Ortho Pan. And I'll do the same for the DEM, export DEM. And we're done. So I'll go ahead and close out of Metashape. I'm gonna not save it, save some room on my hard drive, and then let's open QGIS, take a look at it. In QGIS, I'm gonna add the layer, so add raster layer. I'm gonna make this a little bit smaller so you can actually see it. Come on. It's giving me grief here. There it is, dual P ortho pan sharpen. It's about 2.5 gigabytes. Open that up, hit add, and then close, and there it is. So it looks a little funny because it's probably pulling not RGB layers. And we can go to properties. So right click the layer, go to properties, go to symbology, and then we can select a appropriate bands to make it RGB looking. So let's see, band 1 would be 444, band 2 would be 475, these would be greens, this would be red, 6 is pan I believe, so 5 and 7 would be red, and then 8, 9, and 10 would be red edge, and then band 11 is near infrared. So let's try using 7 as the red, we'll use 5 as the green, and then we'll use 2 as the blue. And then the min and max values, we got to adjust those so that the image looks a little better. Otherwise, it's probably going to be really dark. And if we zoom in on the layers, it shows us kind of where they extend to. So we were using I actually can't remember where we at, 7, 5, and 2. Okay. So we got to look at 7, 5, and 2 and see where they land here. Band 7 looks like it extends to maybe 20,000. So let's do 0 to 20,000. Let's go to 5, and band 5 looks like it's maybe 10,000 to 30,000. So let's do 10,000 to 30,000. And then let's look at 2. And it looks like that goes maybe from 15,000 to 25,000. Still doesn't look quite right. Let's try 6, 5, and 2. Let's just change all these to 0 to 30,000. Let's try that. What we're doing here is we're essentially clipping the values so that it's not grabbing sort of out of range values. Let's try 7, 5, and 1. 8, 6, and 2. Huh, can't quite figure this out. 6, 4, and 2. That looks a little more RGB. Still not quite happy with it, but looks somewhat RGB-esque. I don't like that, how the ground is so purple. But that's essentially how you can create different composites. You can go to symbology and select different bands. So if we want to make a false color composite, we could do 11, which is near infrared, and maybe 9, which is red edge, and then 7, which should be red, and apply. Hit OK. So that's like kind of a weed index. You can play around with these composites to see if you can get different species to pop, like these are weeds down here. Um, Sometimes you can find a combination that makes those weeds show up as a different color. Let's try 10 and then 6. But hopefully that'll get you started on doing some basic image viewing / analysis in QGIS. And yeah, that's kind of from start to finish how you would process the data and then bring it into QGIS and view the layers. Hopefully that was helpful. And if you want to learn more or reach out, you can go to multispectralsystems.com. Thanks.